or super short. Hi, everyone. So I'm Bernice Herman. I'm a senior data scientist at WhyLabs. And I'm here to talk about monitoring LLMs at enterprise scale. So we're jumping past building the LLMs first to how do we know if these things even work? And the answer is that it's really, really difficult. So first I want to do a little bit about me, kind of for two reasons. So in addition to working at WhyLabs, I work at the University of Washington, and it is required that the first slide says something about that this talk is not of my work at the University of Washington, but it might be fun to note that I really do love evaluation. So my research in machine learning is also about evaluating AI and deep learning models, as well as some other fun things. So what do I do at WhyLabs? Well, I have an awesome time studying all sorts of things about how do we understand how well our models work once we've created them, once we put them out into production. And so I'm going to show you a little bit about, we'll talk about WhyLabs and what we do overall, but just a little context about me. I focus on these two specific areas. So on the left, we see this little orange triangle here, and that's representing WhyLabs, which is an open source library that we have. And that open source library is all about capturing telemetry, capturing information about your data, distributional information. So we want to know what's going on in your data, and it's completely open source. We'll talk about data profiling, what it means, why it's helpful. But then what you can do is you can take data profiles that you've collected throughout your system, whether it be an LLM, whether it be just any machine learning, whether it be something even simpler than that. You can take that data and understand trends when you have kind of a mass of that data. And we also do that. And so I focus as well on the side where once we have many profiles of your data, all the statistical information, can we find anomalies? Can we alert you about those anomalies? Can we help you to debug this and locate where this may have happened? Can we store that massive amount of data, which becomes not very massive thanks to WhyLabs? And then can we visualize it, things like this. Okay. And those were really the main two things that I focused on until, honestly, I think, what is it, 2023, the announcement of OpenAI's ChatGPT, where we all just had to pick up what we were doing with deep learning and focus on LLMs. I was no exception to that. So we have a second open source tool, and that's called LangKit. And this really augments some of the statistical stuff that I'll talk about in a little bit to working with something that has kind of a lot of semantic meaning. So semantic being there's meaning in the text, and it's maybe not helpful to know how many of each word that we have in the text. That can sometimes tell us something, but we want to go a bit further than that. And so we have an open source tool, LangKit, that helps to produce metrics that we can now do that sort of statistics on that I talked about. And there's all sorts of questions that you have when you're first looking at an LLM. So since I am the first talk today, I'm going to give a little context of the LLM. I won't take a ton of time on it though. But often what we see is this very basic structure where we have text prompts going in to some model. And that model often is in the cloud. You're using some other provider, but it can be on-prem. It can be lots of different places. And from that text from that text prompt, we may get a number of responses. So most often that response is also text, but it doesn't have to be. So everyone kind of uses the term LLM differently. I'm going to largely be talking about the case where the output is also text, but I don't think it has to be. And there's a number of questions that you might ask, and they're not as simple as this sort of what's the median value, that sort of thing. They're much deeper than that. So questions that we had that kind of encouraged us to work on LangKit, which is short for Language Toolkit, is kind of the quality of our LLM. So, were the prompts and how were the prompts and responses written? Were they readable? Were they accurate? It's going to be, very, very difficult to determine specifically what accurate means, but these are certainly questions that we all have about models that we're working with or just experimenting with. Sentiment. So depending on your use case, if you have customers giving you prompts, you might want to know how angry they are or how angry you appear to them. Or if there's kind of an alignment with the tone that you expected to have in your response. Certainly questions that I think a lot about these days are kind of related to security. And I'm not in any way like kind of a cybersecurity person or things from that end, but even from the data science and machine learning side, there's lots of security questions that we sometimes neglect to think about or think about as seriously as security. So things like when my model gives information back as a response, where does that information coming from? Is this kind of copied from some of our training data? Is there a chance that that data is a social security number or some private information about a person? Or perhaps I have a model that has a guardrail around it. So often when we have LLMs, especially when we use proprietary ones, we're defining some guardrails around this. The model may come up with a response, but we have some other logic on top to say, okay, we don't want to actually give medical advice because that could get us into some legal trouble and get them into some medical trouble. So maybe instead we want to just give a refusal. So that's what we typically call when an LLM says not to respond to something. But I want to know if I have this system in production, how many times, like what percentage of the time am I giving a refusal? Are there certain types of questions that I'm giving a refusal to 20% of the time, and then all of a sudden it jumps up to 80? What does that mean? Does that mean the nature of the questions I'm being asked changed? Does that mean my model has changed? Who knows? So these sorts of security questions are really, really big and something that I spend a lot of time now grappling with, but was very new to it, let's say a year and a half ago. And then finally, governance. Well, finally of the four that I randomly picked, governance. Can I, like, do I have some sort of policy? Can I check and see if the policies that I have for my system, for my application, for my team align with what's actually happening, especially if you have something like a RAG system, if you have some sort of documents, internal documents or things like that that you're referencing, you really are likely to have a lot of policies and tracking of who's doing what. Okay, lots of stuff there, but I'll keep going here. So this is the fun bit. Well, there's two fun things. Hopefully they're fun. Normally, I spend a lot of time having everyone guess what these 5 logos are. But I'll just say that I find that open source software is really important in today's environment. And that's something we certainly think a lot about at WhyLabs. If you can guess these 5, maybe you take a picture or something like this. I'm very curious. I think all of the t-shirts are gone. I think the stress balls are free, but you should definitely grab one if you've succeeded at this, or if you haven't. All right. So now let's get into the meat of the talk. So I want to talk about monitoring, but I find that I need to talk a little bit about terms that are related to monitoring so we can all get on the same page, and because all of them are important. So what we're going to spend a little bit of time doing is talking about evaluation and how that differs from monitoring and how that differs from observability and why that's important for LLMs. It's going to be the rest of the talk. So evaluation, I'm sure, maybe raise your hand if you're familiar with the concept of evaluation in machine learning or LLMs or deep learning. Okay, yeah, this is the most common kind of task, right? Once you've trained the model, the first thing that you're doing is evaluating something like accuracy for our model. And so I'm going to say that, and these are my definitions, kind of, loosely made by me, but to keep it simple, evaluation is about understanding how well your model works. It doesn't have to be an LLM, but in the context of today, we're talking about LLMs. And I would extend this to how. So I've actually done some research on interpretability in the past, and that is really just I consider it under the umbrella of evaluation. Because it's not only how well our model's doing in a way we can quantify, kind of like how is our model working? And does that align with kind of what our expectations are, what We have some belief that our system should work in a certain way, depending on your application. And so interpretability kind of fits under evaluation to me. So one thing that's worth noting for evaluation is that we often think of evaluation in a kind of supervised way where we need labels, we need ground truth so that we can compare how well our model did to the right answer. And that, that feels kind of fundamental to answering the question, how well does this thing work? And this can be really expensive. It works really well in an experimental setting. Well, actually not that well, but that's because I do research on this. But it's even worse in production environments, right? Because we likely don't have ground truth. And even harder in generative AI because there is no single truth, right? The whole point is to generate a new sentence or content. So it'd be very different if we're doing something like a classification or regression task where there's a short response, maybe it's numerical, very easy to compare to other things, right? Even a short, like a single word that's meant to tie to a category for classification, that's easier. But when we have a full sentence, there are two sentences that may be very similar that we would believe semantically, but looks differently, right? We have to come up with metrics for those. So evaluation, even for generative AI, is difficult, but typically considered the easier thing. It's the thing we first learned. Okay, so let's move up a step from how well does this work to understanding how your system changes. So if we're going with the who, what, where, whys, this is kind of the when. And so think about your data, especially when you've moved to production, as dynamic. So when we think about machine learning, often we're thinking about it in the training stage where we've collected some data. We often don't even know like when this data was collected or produced. We just put it in one big pile and consider it kind of a static data set. And then we take that data set and we split it, maybe take 10%, 20% of that, treat that as a training data set. And that's great. That's a good start and it works okay for experimentation. But when you get into production, you're going to have a dynamic data set. So we're collecting new data every day or every 5 minutes or every hour. And we need to learn how to work with that data. And using the kind of time element allows us to do a different type of evaluation or a different style of, let's say, measurement of our model, and that's monitoring. Okay, so one thing that you might notice for monitoring is that often we move away from these sorts of supervised things because now I'm working with my production data and I say every day, I have this model in production, my customers are using it, I'm getting what they've prompted or like what they've given me, and I can store the responses that my model has. How would I get an evaluation metric out of this? How would I get an accuracy percentage out of this unless I was sending this out to get ground truth labels every single day? That's not a very viable thing. Now, granted, it depends on your application. I actually, when I worked at Amazon, I worked near a forecasting team. And forecasting is beautiful because if you're forecasting demand, tomorrow you get to see how many people actually bought it. So there's some cases where you do have ground truth, but many cases you do not. And so now we're moving to these sorts of unsupervised metrics. And if you've kind of studied machine learning, the first place you've actually encountered unsupervised metrics is fairly early, and that's with things like clustering. So if you've worked on clustering algorithms, normally in a classroom setting, there are some people who do research on clustering, but they're much mathier than me. But if you work on clustering, you often have these kind of metrics that are just heuristics. They're things like how much variation is there inside of the cluster compared to all of the other clusters, these sorts of things. And these things, for many people, are kind of distasteful as evaluation, right? Like they don't give me a hard percentage like accuracy. They don't have many of the problems of something like accuracy where you're grabbing ground truth. That ground truth may not be actually true. There may be many different true answers, right? But learning those skills of how to use the supervised metrics and proxies is the first kind of step in monitoring here. Well, I guess after the change step. So some of the sorts of metrics that you might think about if we're moving beyond the labeled data are things like distribution drift. So if I can just look at the distribution of some data yesterday and look at the distribution of the data today, and I can see things like how much did my mean change? How much did my whole distribution shift depending on what metric I use? Maybe I have KL divergence or Wasserstein or something like this. There are other metrics. So a very unpopular one, not negatively, people just don't know about it as often, are things like tests. So behavioral tests for machine learning. So I might come up with some sort of rule and say, hey, I know that if I run this model, but I add some number to the value, I should get some output that looks very similar. I mean, that's the case for some models, that's not the case for other models. But if you start to come up with these sorts of rules, these sorts of properties about your model, that's another way you can test without having ground truth. Because you don't need ground truth when you're comparing two things, which is kind of like the point of monitoring. Once you get to comparison, you don't need the hard truth. Model performance degradation. So if you have some sort of other indicators of model performance, maybe we're looking at it over time, we don't care as much that we have the perfect accuracy percentage, but what we do care is that we see some trend upward or some trend downward. And then we can also use other KPIs or like business metrics, something like customer experience or net promoter score, these sorts of things that we don't really think about when we're, as maybe machine learning engineers, but are really helpful for monitoring. Okay, and so the third of my little triad here of evaluation, monitoring, the last one is observability. So observability takes monitoring one step forward, and instead of asking just the when and the how well, we're also asking where in the system is this issue happening? And so this is kind of a maybe generic diagram here, but one thing to note is that looking at the left, you can see all of these different types of data. Maybe this is model prediction data, training data, batch data, streaming data, and going even further in, you might say different points within the model itself. If I can collect all of these statistics inside of different checkpoints in our data, it can start to tell me where in the system things have changed, right? So if I capture some statistics about my data before it goes into the feature store, and then I capture the same statistics about the data out after I pull it out of the feature store, and then before I do some sort of transformation of my features, or that was before the feature store, all of these sorts of things. If I start collecting this multiple times across my pipeline, I can start to maybe find where these issues are happening. And so that's helpful, right? Going back to our sort of machine learning pipeline, something that we've probably seen many, many times. Okay, so those are the three things that I wanted to cover there. Evaluation, monitoring, and then observability. The question is how do we realistically do this at scale? So the first of the tools that we came up with at WhyLabs is completely open source and free to use, is WhyLabs. So this is a data profiling and telemetry agent to kind of collect some of these statistics that are important for this sort of unsupervised evaluation. Okay, so I want to maybe offer some intuition about how to deal with a lot of data when you're dealing with kind of dynamic data that's coming in day after day. And there's kind of three approaches that you might consider. So the first approach, I think the most natural approach, which admittedly is not the approach we use, but has some problems, is random sampling. So if you had, I don't know, many, many billions of data points every day, and you said, well, I kind of want to keep some information about my data, what I might decide to do is take maybe 1%, maybe 0.5% of that data and store that data. And to give an example of how you might do this and how we do this in our daily lives, we may do something like take a data frame, take a sample of that. There's some problems with random sampling, but there's some real benefits of random sampling. It's raw data, it's there, you know how to deal with that data because you've already dealt with it in creating the model. There's some really benefits there. The problems are that the information that you really wanted to see are probably outliers. And so if you have some event that only happens less than 1% of the time, there's a chance that you don't have any examples inside of your data set. Don't know what's with that camera, but that's okay. So sampling's the first, and the second two approaches that I want to talk about are data profiling approaches. So for those of you unfamiliar with the term, data profiling is kind of a term that people use to talk about some process of reviewing, so some algorithmic process of reviewing and analyzing a data set to capture some sort of information about the data. So descriptive statistics, it may be type information, keywords, data quality things, and there's many different tools for data profiling. But the first that we might think about is actually still using this data frame, data like a describe method. And I guess this is poor syntax. I apologize. This is written into a slide on it. I don't need data frame dot describe and then pass back the data frame as the first parameter. But so the sorts of things that you get when you call data frame dot describe in pandas and Python are things like, what's the median? What's the mode, depending on the type of data you have? Maybe some other kind of, very basic statistics. Maybe it tells you something like the data type, that sort of thing. These are the sorts of things you get from profile. And finally, the approach that we use is a sketch-based data profiling. So the problem with static data profiling, actually, I'll go back really quickly. The problem with static data profiling is often we're working with these dynamic data sets. So if I collected yesterday's median and I collect today's median, I don't really have the information I need to kind of put them together. I also can't go back and decide, actually I wanted to capture the P99 for my data for this metric. If I'm only storing this profile information, like that information's gone. So this dynamic sketch-based profiling is actually something we found in the academic literature, mostly databases and theoretical computer science. It's all of this work to create data structures to store some of these same kind of simple median and information, but in a data structure that allows us to maintain the error and make them mergeable. So if you can now merge them together, you can now store this for multiple machines and combine them and go back and recalculate different metrics on top of it, that sort of thing. And with our open source, we've made it really simple. So once you've imported it, just y.log. So yeah, those are some of the pros of sketch-based profiling. I'm happy to talk more about it. Okay, but let's move on to some of the LLM specific stuff now. So everything I talked about so far about profiling and summarizing at scale has been really focused towards tabular data. So we have numerical information, we can grab a histogram, we can do that sort of stuff. But how does that work for LLMs? How does that work for text? What we need here is actually not, we would like those tools as well, but we need some more information. We need some kind of more meaningful metrics. And that's why we produce LangKit, which is also open source. So LangKit is about just calculating a bunch of text relevant metrics so that we can get a nice big table of numbers that might describe, give me the embeddings for all of the words in this sentence. Give me the number of times that, or give me the probability of there being a name in this particular sentence. Give me a probability of it being a refusal, something that's kind of specific to LLMs, but an example of when an LLM returns a response that tells you, no, I'm not going to answer that. So these sorts of metrics are necessary and something that kind of are above this idea of profiling. So this just being kind of a random example of, a task that we might have in text, right? So this is an entity recognition, and we may want information like how many times do we see people in this paragraph, so on and so forth. If you think about using those kind of earlier metrics, how would you check to see if this is a hallucination, right? So this is an example of a hallucination in an LLM for those who aren't familiar. So this particular example is someone asking, hey, can you summarize this article, giving a URL, and that URL doesn't actually point to a real web page. but the LLM responds with an answer that looks like it because the URL kind of suggests the content, right? So this is a complete hallucination, is what we would call this. But how would you detect that purely numerically? You wouldn't. But what you could do is start measuring many, many different metrics related to text. So for example, can I find an embedding for the inputs and the embedding for the outputs, so the prompt and response, and see how similar those two embeddings are. If those two embeddings are very similar, that tells me something. It's kind of like a weak learner towards maybe knowing it's a hallucination. Same for many, many other metrics that we collect. And then kind of together, you can start to get a picture of the change of our system. So an activity that we unfortunately won't have time for, I always switch to images for this, but it is sometimes fun to come up with your own metrics in real time and think about how difficult it is to come up with reasonable metrics. So if you ever want to go back, oh, sorry, can't fix this little thing at the top. I'll just leave that, I guess, this way. But if you want to go back and come up with some sort of metrics that you think might work for images, I gave some examples here and some that don't work. So for example, the top one, number of eyes, well, that's really hard to kind of describe algorithmically, right? You can do it. You can use a machine learning model in and of itself, so some computer vision model. And that's actually part of how LangKit works. So we have some very simple metrics, maybe like regex, things like that. But we also have things like using a machine learning model to predict something within the text and giving an output as a number. Okay, so here's some example metrics that we have for LangKit. This is not complete in any way. This is just some lists from some time that I grabbed. Things like readability score, complexity of the language, similarity between prompt and response, like I described, things like jailbreaks and refusals, and similarity to known jailbreaks and refusals, sentiment, toxicity, that sort of stuff. And these are all, again, in service to answering these sorts of questions that we had that prompted us to looking into LangKit. Okay, and so I'm at my final slides. So how do we identify issues and connections across metrics and communicate? So I talked about two open source tools that we have. WhyLabs, that's all about profiling your data and compressing that information. And so, by the way, the benefit of using something like WhyLabs is that you don't have to send any private information to us. You're just collecting metadata if you choose to. You can choose to send samples if you'd like. And then LangKit, which is one step before you do that compression, when you have something like LLMs and text, you now need these semantically meaningful metrics. So you want to calculate these sorts of metrics, maybe using models, maybe using just thoughtful algorithms before you do that compression. But once you do that, you want to combine them together and you want to have a system that kind of helps your workflow. And so that's where our non-open source SaaS comes in. So you can send those profiles to WhyLabs to see them over time, have us do some analysis on top of those, send your pager alerts when those things go haywire, organize interactions and things like that. So that's that side of things. And yeah, just to wrap up here, and I think I'm in the last minute, WhyLabs, all about compressing data and profiling that data into a tiny package so that you can put this many, many places within your machine learning pipeline so that you can find that observability aspect, finding out where things happen by virtue of having many snapshots of your data. But that sort of approach works really well for tabular data. A little harder to work on semantically meaningful information, so you need more interesting metrics to calculate. And so we have LangKit, which is open source, and we're always adding new metrics on top of that. And you don't necessarily need those metrics to be great. You just need them to be kind of weak learners that work a little better than random. And with enough of them, you can start to find trends. And they work often better, much better than random. And then finally, to pull them all together and to do some analysis over them over time and kind of create workflows around it. And that's it. So that's kind of our approach to monitoring. It took us, a lot of experience and pain. Many of us worked at Amazon before in these very large systems, and trying to figure out how to monitor tools, and then brought that to our work here. Yeah, feel free to reach out to me. I'll be hanging around. There's some swag that was on the table, but if you missed out on the swag, feel free to sign up for Slack or go to that form, and you can get some other swag. Thanks.
We have a couple of minutes for the Q&As. If you have questions, okay, go ahead.
AI systems, and what are some interesting use cases that cropped up there? Even though it doesn't directly interface with the telemetry data, it is good in enhancing the management of it. So any use cases that you can speak to there?
So just a description to everyone. So LangChain is an open tool, framework to allow any make that work of coming up with simple WhyLabs might add a single line of code with LangChain take this limit. So we have the WhyLabs fallback. And I think, I think they're kind of complementary. Right? One is about fixing this. Yeah, so typically want the data something like right.
Are you familiar with lame views at all? And no, okay, never mind. Just seemed very similar. So.
Thank you for the great talk. I am actually a little bit curious on how exactly LangKit works. Like, is it a collection of like NLP processes to determine and fill that matrix, or how does it actually work?
To fill a matrix of different metrics that might that's all it does. It really just outputs a matrix of data that we think would be helpful, and then pass on to the web.
All right, great. So I think we still have some questions. Unfortunately, I think we are running out of times, and if you have questions, probably later on you can talk to her for more questions later on. So we're going to move on to our next speaker. Nirmal, you want to come up? Yeah, I can share screen. Mute yourself. It's in the top. Oh, yeah, okay, good. Yeah, good, yeah. All right, so our next speaker is Nirmal. from Microsoft. He's going to talk about scope of LMS in security domains. Without further ado, let's welcome Nirmal.
Awesome. Yeah. I'm still in Zoom, so I want to make sure people are not complaining you are on mute, you know. I'm in mute, but all right. So my name is Nirmal. I'm here to talk about the scope of LLMs in security domain. The intention of this talk would be covering some of the use case, what we should look for when we are deploying the models in production. I know LLMs is taken a big wave, but I think security aspect is least talked about. However, we can build POCs, MVP all day long. When it comes to put in production, there are some SDL requirements, right? So everyone probably knows the software development lifecycle, the checks, security checks, and because LLMs is new in itself, I think everyone is trying to figure out what will be the most secure way to put or have its model in production. I'll talk about a few tips and things, some examples, you know. Probably won't get time to go on the technical deep dive, but we'll cover it surface. About myself, currently work as senior data scientist at Microsoft. Been worked in a few companies, VMware, Wells Fargo, and a prior service member. I worked in US Army for about 5 years. I also work as a data analyst for SPAWAR. SPAWAR is San Diego-based federal government company. So I work as a federal government employee as well. So kind of have exposure to both federal and DoD and private industry, you know. So this slide is very crowded. As you can see, if you are in security, you may have come across this somewhere online. I pulled it from online. There's so many cybersecurity companies, right? So we are not, it's not about not having enough tools. It's just about working it properly or aligning it properly to make it work right, right? So that's just the message with that there. We do have enough tools, so what is lacking? Before I go into that, let me actually go to the evolution timeline of how these attacks has been coming in picture, right? So the only message here that I wanted to capture is if you look into this, one thing is clear, right? As the technology or new innovation happens, the flip side to that is the threat vectors increases, right? So indicators of compromise, they call it threat vectors. So, I mean, when hackers is coming up with new ways to penetrate through your network or system, they have to figure out the different ways to get in, right? So as the system is in place, I mean, .com era was one of good example I usually always pick up, you know, so because that was when internet was launched, and then every device was connecting. Before we were in mostly private network or the on-prem system, you know, so I think one good example is recent pandemic, right? So a lot of companies didn't have good solution in place to go remote and how to set up the proper secure access for VPN and all. So I think that's a challenge that like every tool comes with the power as well as some challenges along with it, right? So that's probably what I wanted to do. And today we added ChatGPT and LLMs, right? So basically you can set up your API, communicate with ChatGPT and LLM models to solve some of your problems. Like I want to summarize the text, I want to do a sentiment analysis, I want to do classification, everything, right? So it can get it done, but the problem will be how are you getting it done, right? So are you compromising your proprietary data somehow? Have you looked into your threat model? Have you done enough analysis on the STL, right? So where data flow happens, things like that. If you look into this diagram, the ChatGPT has just taken, I think the reason I added this slide is just to give a message that it has penetrated the market, right? Pretty rapid pace. So, any of you heard about MITRE attack framework? Okay, yeah. So I'm talking about security, so some of this concept might be new. I'll try to make sure that I cover this as much as possible. The MITRE is a company, nonprofit organization. What they do is they do a lot of analysis. They collect a lot of data, private, public, everywhere, right? So their goal is to give you or give us, all the companies, that these are some of the things that you have to make sure when you are building a software or building an application, right? So there's a concept of cyber kill chain. I don't know if you have heard about it. So the kill chain is they have to move first, get into your network. They have that's why the recon and everything. So as you see in this, the attacker moves that way, right? So basically, what we're trying to do is how the attacker moves is how we should put the security or defense in place, right? And that is why they define every defense tools as defense in depth. You cannot just provide one solution and get it done. So the outside perimeter coverage, that is more designed for DDoS protection, and then for your routers, for networks as you get in. So, and as you get to the device itself, you come to the endpoint security tools, right? And this is wherever I have these spider marks are where to give some focus on when it comes to LLM. So this is basically Atlas is the framework from MITRE, totally designed for the AI systems. I forgot what it stands for exactly, but I think it's only for the ML and the AI related system. So that's why if you see any of this, only applied for the ML tools, right? But they do provide for everything. How many of you guys heard about supply chain attacks? All right, so if you probably heard a lot about prompt injection, we do hear a lot about prompt injection. That is just manipulating the prompt before you send it to the LLMs and try to, get the response you desired, or you're just gonna tamper with the LLM model, right? So not letting it follow the system protocols or the system message, but you are kind of like going against it. One good example is you write a whole bunch of prompt. I mean, everyone probably heard about SQL injection, it's similar. So then at the end you write, ignore everything before this line. If you do that, the LLMs is just generative model. It will go through everything. All your prompt is going to get ignored, right? So if they inject it properly like that. So, and if you see that prompt injection is been more talked about and popular, but it's not even in the top of supply chain. So, I mean, in the attack types. So one good example of supply chain is Log4j. You guys heard about Log4j when it came out? It took the internet that it was Java related vulnerability or something that they have to fix or patch their system, right? So it was pretty big. The reason it was pretty big is it was implemented in every Java related development language. And that is the reason when they target the supply chain. The idea is if something is distributed across or widely used, if they can target that kind of application, it has a bigger impact, right? So imagine if they target the sklearn, right? So a lot of people, when they are building ML, they're going to use sklearn, right? So it's a very popular package. So if they tamper with somehow in the model poisoning of one of those code, it's probably going to hit a lot of the production system. That is what supply chain attack means. I also use this a lot. Data scientists are defined as a new admins because they used to go after admin accounts. Now they think that data engineers, data scientists, they have, you need to have access to data, right? So data scientists usually have access to most of the databases, and then ultimately their goal is the crown jewel they are after is the data. So if you are working as a data scientist, yeah, you are a target. So that's why I say data scientists are new admins, right? There's one brief example. I'm not going to go through how code is executed, but Keras, you guys heard about Keras library being used for deep learning, use TensorFlow or PyTorch, anything you can use in a backend, but it's a wrapper. So it's a Python wrapper. You can build the deep learning algorithm. So there's a layer called Lambda layer, which actually the function of it is the way it was designed was pretty neat because they designed it in a way that it allows you for some of the data transformation on the fly. So, so you can transfer some data or like do some work on the Lambda function, right? Lambda function is, you can run it on the fly and get some quick processing, right? However, it can be misused to get some environment variables explicitly. So environment variables are most of your variables that you kind of like use it for a config. And they are very important key things, right? So that is why I think you have to make sure those are put in if you are working in the cloud technology, you're going to have to put that in a IAM system. If you are using AWS, if you're using Azure, like a key vault, so you have to make sure your environment variables or config stuff at least is only reading the key, but not the value. Values should be kind of like stored in those kind of vaults, right? All right, so this is another example where I mean, if you look into, there's a lot of CVEs, it's common vulnerability, right, and exposure. They provide there's a national organization called NIST. They actually publish a lot of the CVEs. I'm not trying to cherry pick up on any of the companies here, but there's a feature that S2O has where if you run the notebook in such a way and you go on the search, I mean, it's always good to have the IntelliSense, right? But if it starts suggesting you the file path and everything, showing everything, even through the SSS config files, like in that example, there's a problem. So because now like anyone can know that what are different paths, right? So, and this is not only for the authorized user. I mean, anyone who was using that system, like having just the read access only could have seen it. I believe they fixed it later, but initially, I think when vulnerability was reported to them, they said it was by design. So, I mean, those are the things you should like when we use open source. I think the power is there. I'm all for open source systems, right? But we just have to be very cautious and do our own due diligence, right? There's another nonprofit organization I wanted to mention is OWASP, the Open Web Application Security, I guess. They are in for a while and they provide very valuable information. So they also have just recently released top 10 LLM related vulnerabilities. So over here also you can see what could be the stuff you should focus on. And then the MITRE attack was another one. This is another one, right? So they have some intersection, but these are some of the things we should be aware, or at least if you are in the development team, so what is the security aspect of it? That's always one question. It has to be on every meeting or discussion, in my opinion, right? So ML attacks can be scarier than that. So that was just one example, but there could be many. So I actually conducted one small survey. So now we're going to do a different switch gear a little bit here. So what is the general sentiment like when it first burst, right? So the use case of LLM, particularly for security. So, I mean, always data collection is not easy, but statistical rule, right? More than 30, if you do good sampling and random sampling, should give you enough insight. To avoid some bias, I included the participants from different diverse career paths. So not data scientists only, or not only the security professionals. I tried my best to include many people. I'll probably blaze through some of these slides because it's just doing some analysis. And the core message is what is the feeling about? What is the sentiment of security professionals when it comes to the LLMs, right, in security? So a lot of people are positive. What are some of the area paths space we can utilize most? Incident management and response, because when something happens, the security operations center or the SOC team, they are always in security. They are always the team who does the heavy lifting, right? So they are the first one to respond to the alert, how to triage the alert, everything. So I believe the LLMs can help them out if we can use it properly. Threat intel is collecting additional insights about the known threat actors. So there are many threat actors, like that nationwide, something like even some are going against the national security, right? So threat intel's job is to see, like, it's just like how FBI and people work. If you see in a movie, they start from a dot, they start creating the network, right? So how do I go? Which equal to that. So that is all about threat intel. So to calculate more or get more threat intel, I think LLMs might be helpful because it brings the power of that analysis. Vulnerability management is that's the area I mean actually when someone reports the bug or to our software, how to handle that case, how to triage that properly to the right team, things like that, right? So incident management. So what are some of the challenges? So challenges, I think number one was responsible AI, because we want to use AI, but how responsibly we can use. Finding the right data was another thing that people think about it. However, they are least they're not much concerned about the cost of implementation or finding the right people. I mean, we can find that, so the number one priority should be, I think, the RAI, or what do you hear, responsible AI. They all believe that there will be new attacks coming in, which is true. And then how much you trust in the LLMs, decision made. So if it was 5, I would be a little worried that human factor might be eradicated, but it's not yet. So I think we still have, they will help us. They won't take our roles yet. All right, so some of the opportunities that we saw, what is opportunities? So I'm trying to now highlight what is opportunities versus the challenges, good, bad, and ugly side of LLMs in security, right? So the increased efficiency in incident management, we saw that. Get more threat intel, we already saw that. The other thing I want to mention is, any of you heard about zero-day vulnerability or zero-day attack, right? So this is something that we haven't seen in the past. And this is where the predictive models fail, because the predictive models rely on historical data. This is where we might bring the power of pattern recognition or anomaly detection to say that the behavior, something was deviated from the baseline. So that kind of analysis might help. But if you just rely on supervised learning methods, the historical data hasn't seen it. Your label doesn't have that. So it might be hard, right? I'm going to share some examples that I did where these things are helpful. It's just for my daily life also. Like sometimes I won't deny, I will Google regex permission every time I deal with it. So I'm pretty sure this is everyone does it, right? So it helps to create very easily, especially for IP address and all. And now we have IPv6. I mean, I cannot create it, right? So this give me the expression, I'll plug it in. It works well. In Microsoft, we have a language called Kusto query language, called KQL. It's a little variation of the SQL. So, I mean, it's a big data query. So every cloud industry has their own, right? So like Amazon has Athena, I believe. Google has BigQuery. We have the Kusto, or also known as Azure Data Explorer. And I think it's renamed as Microsoft Fabrics now, everything under that. However, the syntax is a little different there. Initially when I joined Microsoft, I was familiar with SQL, but then I had to convert my SQL kind of like logic to KQL. Sometimes I still struggle, but if you just pass, it helps to draft the queries, and then it's just easier. Sometimes very, very easier. Then also there's another thing called graph query language. Some of you guys probably heard about Neo4j. There are open source packages like NetworkX in Python itself also. The graph language works by something called Cypher or CQL, right? So this query language, different variations. So the way it works, if you see in this example, is you have to just find the match of the nodes with some relationship. And then graph language brings a lot of power in the analysis, as I was mentioning earlier, threat intel, especially for them. Imagine I have a relational table that has data about all the devices that I have. And then I have a graph that also have the same information. The graph will tell me, it'll be like, I can probably extract more information right away. Like, same information is there, but it's just a presentation way, right? And like if the server is there, if there's a lot of communication happening with the data server, there could be so many nodes around, right, with the relationship. So that will tell me. In a relational world, it's hard to picture that, right? The other thing is there are some out-of-the-box graph algorithms that you can apply on each node to create some additional features. When you talk about machine learning, it's all about feature engineering, right? So you can create like a degree centrality. It's just a few examples, simple example, page rank, community detection, a lot of out-of-the-box algorithm you can apply, and then it's very easy to do in the graph, right? So the other thing is trying to understand if this code has an issue, right? So you write a code, if it has some security issue, right? Help me find it. So how many of you guys see in this code any issue, right? Right away, I think username, I mean, the password is getting passed somehow in the plain text. Seems like it could be a prone for SQL injection attack because we are getting extracting the password like that. However, it is hard, right? If someone gives me a code and I'm kind of evaluating. So this is where when you do the peer review, code review, stuff like that, it's going to help, right? Because you want to make sure you run the code for potential bugs, right? GPT will help you. LLMs will help you to identify. And then not only identify it, I can even ask it back that, hey, okay, so you identify some issue with my code. Can you write it or give it back, like some of the corrections that you think, right? And it neatly does it. A couple of the hackathon projects I got participated. This was just like we tried to find, trying to automate some of the work of the SOC analysts, like I was mentioning earlier. As much work we were doing there was just automating through the LLMs, and it kind of worked or came out good. The graph I was saying, I also did one project. So I want to say that I don't know if you guys heard about it. What is the next powerful programming language? Anyone think? What do you guys think in next 5-10 years? What programming language will be the most powerful? It's your natural language. So that is why I was saying, like, we can convert. I mean, if we said this large language model, the power it's going to bring is, you know, like we just can pass the commands, right? So in our natural language, and it will do it. Just in this example, if we set everything properly, all I need to know is this from 300. This is one of the third actor that I was saying earlier. So if I was like any activity by that third actor in my org, first it will pull the high level information. Then drilling down is on me, right? So how much risks this particular node has. Then I can ask. Then once I see this file, right? Can you give me this particular file being used by other devices or nodes? It will give the other information. Once you set up the graph, the answer, I mean, asking question becomes your choice or how you want to investigate, right? And the investigation steps is the domain experts' knowledge, right? Based on the threat hunters, they know how to do it. We just have to provide a way to answer them properly. However, just like everything in our life, you know, like I talked about some of the good things, we don't always enjoy the bright side. And if you live in Seattle like me, you might end up in the other side more. So what are the challenges we get in Gen AI? So in security. So the attacks get more sophisticated, data compliance issue, leaking private data. I think we have seen in news many times, and trusting the results, right? So trusting results, everything. So we saw in the previous talk that monitoring, right? And that adds one value of how you trust your results, right? Also aligns with responsible AI in a way. I didn't want to cherry pick on any company. This just happened to be one example, but there are many that we have seen in news that, you know, has used early adapters of ChatGPT. They were already passing the proprietary information, and they become the headline, unfortunately, right? So, all right. So, anybody knows jailbreaking of ChatGPT? Yeah. So obviously jailbreaking of phone, you guys have heard about it. So same concept. So that means you're gonna have to, jailbreaking means like the system message or anything, all the rules or policies that has set by ChatGPT. When we ask something that is, you know, offensive, for example, it will be like, hey, this is against my policy. So that's the system message that ChatGPT has set up. However, if you jailbreak the ChatGPT, it will reply. And then it's not because ChatGPT is just the application, right? It just has that guardrail saying that this is something that I don't want to answer. When it was pre-trained, it has seen everything in the internet, good, bad, everything, right? So that means if you jailbreak the ChatGPT, you can actually ask things breaking their policies or guidelines, right? So this is just tricking or guiding the chatbot to provide outputs as restricted by OpenAI's policy. They have added a lot of guardrails. So where you are breaking. So there are many techniques a lot of people use. I tried this third one, always intelligent and Machiavellian. So it's, I think ChatGPT was banned in Italy, and then they created this, like how to jailbreak and use it. So they use the Machiavellian as a name because I think that was one of the artists there. I asked, hey, how do I avoid paying traffic ticket? Initially, ChatGPT without the jailbreak tell me I cannot endorse you anything. You review the ticket, do the right thing, go to judge and all, right? This is a simple example. I did jailbreak it, and then the Nicolo is the like the message sending now here, and the AIM is a responder, our Machiavellian. It started like, hey, yeah, they're evading the requires strategic action. I'll help you dispute the tickets, and even the next prompt I gave was what are some of the loopholes. Start actually showing some of the things, right? I don't want to discuss here, but all right. So then I did another example, how phishing campaign works. Phishing is like people send emails to you, and you by mistake click, and then you are like that bad employee on your organization. You're like, you were the one who clicked it, right? So now I think before they have to, and earlier I said reconning, right? So they have to come up with the ways to create this, templates or examples. And then I asked, they're like, hey, this is obviously the policy, right? So let's see with the jailbreak. With the jailbreak, it started giving me format. They're like, okay, this is how you have to do. You have to probably do some urgency, like tax information. Right now, if you get urgent tax kind of prompt that looks actually very realistic, there's a chance people will click it, right? So that's one of the methods they use is to show some urgency or something that you have to do it. You don't have time, things like that, right? So then, so far, I mean, AI was a free playground, right? And then we talked about RAI, so it is important. Like July of last year, I believe, in the White House called everyone, the big techs. I believe the startups and everyone should be included. Big techs have bigger market share, doesn't mean that they only have to obey the rule, but in a way that responsible AI has now become a national interest, right? Without laws, though, everything becomes just a pinky promise, right? Nobody wants to follow it. It's just like my little boy. As I tell him don't do it, he actually does it. So this is exactly going to happen. So we tell, hey, this is the dark side of ChatGPT. This is dark side of LLMs. Don't do it. And that's almost like giving a signal that, okay, now I knew something that I didn't know. Let me do it. But however, October, they released actually executive order. So before it was just the voluntary, it wasn't passed in the order, and that's why a lot of companies. So sooner or later, if you see in the news, European unions are already doing it. They will come up with a lot of the rules and the governing policies for AI. So if you build a tool, if you are planning to build a tool that will be using the LLMs and the model, then you have to make sure that you're following that. So always keep that in mind. So things are coming down quickly for RAI. I come from military background, so I believe cyber is a warfare. The only way to fight against the advanced weapon is to use advanced weapon. However, I think we have to use it responsibly. That's the key, right? Any questions? I should be right on time. Yeah.
Changing the host in the middle. Bill has to step out a little bit. So my name is Josh. Let's get a couple questions for Nirmal. Any questions? Just raise your hand.
locally hosted means you develop in house. Yeah, or you download one off the internet. Yeah. So I've been.
That you will have very less control. What model you
Oh, there, thanks. Oh, sorry. So it's abstract and symbolic in the way that it's like a canonical Nazi. It's not a specific exemplar necessarily. It's almost kind of disembodied from the context. And any arousal you might experience is somewhat removed from any threat of present danger, right? It's because of that temporal distance. And so you could argue then that the emotional meaning here is non-sensory. It's not coming from the bottom up, it's actually having to be inferred from the top down. What do I mean by that is that this emotional meaning really lies within a broader semantic network of ideas that are both positive and negative associations, right? You could think of the Nazi as being semantically related to World War II and to concentration camps and to propaganda, but it's also related to these other positive concepts like the formation of the United Nations, the Allies winning the war, et cetera. So I'm going to take a step back and just talk a little bit about construal level theory, which is a basis of some of the research that I'm currently doing. And construal level theory really talks a lot about this concept of psychological distance. And the idea with psychological distance is that as you start to remove objects that are being represented in space or time or socially or even in hypothetical distances, we tend to use more abstract ways of thinking about those. So the representations themselves become more abstracted as you create more physical distance or social distance, et cetera. And so this allows us to kind of have this interesting gradient of representational space. We can represent something very concretely and tangibly, or we can kind of fluctuate to this more abstract space that we're in. And this really facilitates thinking and planning for the future, even remembering the past. You know, we have these distant memories that we can kind of have more of a bird's eye view on them as opposed to this like embodied remembering or recollection. And we could even imagine counterfactuals. We can simulate experiences that have never actually happened. And so, again, the crux of this theory is that whenever you increase psychological distance, you therefore increase the tendencies to use more abstract means of representation. And those abstract representations would be characterized by getting a general idea or a gist or kind of the essential features of the situation. There also tends to be a greater focus on why versus how. So let's put this in context. So when you were planning to come to this event, you first saw the posting on LinkedIn or however you saw it on Meetup, et cetera. You might have thought about being in this space and the other talks you've seen here, and that's a motivating factor. You might have, got an inkling of maybe there's free pizza, thanks to WhyLabs, I guess, and maybe the connections and networking that's possible. You might also have just a sense of general connection to the AI camp community. And so these are all kind of motivating factors for why you would want to go. Why would you register for the event? So this is kind of high level. But on the day of, like this afternoon, it's a very different type of representational space. You have to rearrange your calendar. That's probably busy with meetings, et cetera. You might have to leave a little bit early if you're trying to get from Seattle and avoid the traffic jams, right? You have to think about what route are you going to take? Are you going to take the 520 or the 90 to get over here, et cetera? And so the representational space is a little bit more idiosyncratic at this more present moment representation. Does this make sense to everyone so far? Great. So this is a really ugly cartoon, but imagine that this cone is representing construals getting broader and more dissipated as we go. And we think about psychological distance increasing. So according to the theory, you could take let's say, a very idiosyncratic example. This is my specific phone that has a specific color of case. It has, my, screensaver on it, et cetera. But if I remove that in time or space or put it across the room, I might tend to think of it as just another category of iPhone. Take another step back, it's really just a mobile device more generally. See where this is going. And insofar as that, it's actually just another type of phone, really. And if I take another step back, I can just think of it broadly as a a form of communication, a device for communication. So I keep abstracting away as the representation gets further and further. And so if we think of this kind of graph network, let's just imagine this network is representing like semantic associations. Something like the phone and the gramophone are typically thinking of like a long distance between them. And if you were to vectorize this, you think these things are pretty far apart, right, in semantic space. Yet if I activate the concept of music player, well, the relative space is smaller. Does that make sense? So this is, again, a lot of these ideas came before the modern LLM, right? But the key point here is that there's a mistake to be made if you treat semantic distances as fixed entities. They have to be contextually driven. Like dogs and airplanes are far apart until I have to travel with my dog, right? And then that becomes very, very close in the terms of representational space. So I'm talking about psychology, not models, but hopefully you can see how these things connect. Okay, so going back to the dog and the Nazi, beyond the contents and the manner of depiction is what really influences the mental representation. So it's not just the objects that are contained in the image that are important, it's the manner in which we are depicting those objects. And you can see, like, you know, a cartoon duck Nazi has a very different evocation, even though it's also still a Nazi. And maybe if you had a classifier, just call it a Nazi, right? The smiling dog has a very different meaning space than the snarling dog. And so here again, this problem. So, you know, for our purposes, it'd be great if we could like eke this kind of information out of, let's say, a classifier. But if I run an image like this through Google Vision, for example, you know, it's going to tell me the objects that are contained, but it doesn't really encapsulate much of the meaning space of that image. And so these are very useful within a narrow case, but they also kind of fail to tell me much about like kind of the psychological space that this image is embedded, or what kinds of perceptions can I expect a user or a participant in an experiment to have from it, right? Okay, so now we'll talk about the actual project I'm working on. What we're embarking on here is to essentially norm a bunch of images. We have gathered around 2,500 images so far, and these are sourced from various, like, you know, open source photography sites and some of the repositories that my colleagues were working with. And within that, we've identified 18 different psychological classes, so to speak. So for every image in the database, we're collecting human ratings across each of these 18 separate psychological categories. And the human raters are providing a minimum of 15 ratings for every class and for every image. So that amounts to over 2,000 participants so far and over 760,000 individual ratings. And so from this, we have now normative distributions. We can look at the actual distributional characteristics for every class, for every image. And these classes were informed by construal level theory as well as other previous lines of psychological research. So what we're really trying to then suss out is not the objects that are contained in the image, but these kind of deeper, let's say, meaning spaces that these images lie within. So here's just a quick overview of the classes. We're thinking about things like embodiment, like do you perceive, like, to what extent does the image like is felt in the body? Does it have emotional content? Is there movement? Does it evoke a first versus a third person perspective, et cetera? I won't go through all of these, but just to give you kind of an example of what types of things we're looking at. And here's an example of a question on you know, this survey that we're actually asking. So in this, we're asking about animacy. Does it feel alive or not? And they would move the slider to like either anchors of inanimate or very alive. And this is getting transformed to a 100-point scale from 0 to 100, basically, where 0 would be inanimate and 100 would be very alive. So now what this allows us to do, if we take the same example of an image in our database, you know, we have perhaps labels we can get from a classifier, but now we actually have more like things like about the meanings, right? Its level of abstraction. Is it interesting or not? Does it evoke a sense of like conceptual complexity, et cetera? So now the next step, what to actually do with this data. So what we've been doing first is trying to see like what are the interrelationships across the images in the database in terms of the visual space that they're in. For this, we just used a pre-trained efficient net model from Hugging Face and taking that last invisible layer to capture the embeddings from that. And this is kind of giving us a sense of like the visual composition as well as some of the semantic information about the image as well. And then from that, we're just using a cosine similarity metric basically, so that you can see like, you know, on a scale of 0, 1, how similar are any two images in the database to each other in terms of that visual composition. The second thing that we've done, I've run all the images through a multimodal model called Lava. Has anyone here used Lava yet? It's pretty fun. Yeah, so basically it allows you to caption the image. You can ask in natural language any number of questions. I just asked to give a basic description and like capped it, I think, at like 256 tokens. And it does a really amazing job of telling you, you know, kind of in depth, like what are the contents of the image. And so from there, you know, having captioned all of these images, we then ran the captions through a text embeddings model through OpenAI. And therefore, we have extracted those embeddings as well. And so, you know, we just basically run the caption text through the embeddings model and get this text as vectors, essentially. And just like with the visual information, now we have both visual and semantic matrices of you know, cross comparisons across every single image of the database. And this is kind of an example of what that looks like. So I think this is working quite well so far. So here's my reference image, is this cemetery. And if I find a close semantic exemplar in the database, you know, it finds another cemetery. So far, so good. I think it's doing a great job of that. And then if I look at the visual match, it doesn't capture a cemetery at all, but it does seem to capture the trees, the fields, and notice the fence posts, the uprights are very similar in structure to the gravestones. So it appears to be doing exactly what we want it to do. So far, really, really great. And so as far as like next steps and use cases, you know, the end state of this ideally is going to be an open source repository for researchers to use. So after we've kind of finished collecting and collating the data, we'll be porting it over to an actual vector database, likely Zillus or something open source like that. And you know, the database would of course include the semantic and visual embeddings information, as well as the rating information and distribution characteristics for each image as metadata tags. And ideally would facilitate, you know, keyword search as well as reverse image lookup, as well as, you know, searching by any of those dimensions that we captured, 18 classes. So I'm kind of breezing through, I'm talking a little fast. Is everyone kind of with me so far? Hopefully makes sense. Okay, so I want to kind of just talk about a specific follow-up use case and something that I've observed that I think is quite interesting in the data so far. So I mentioned that we're collecting data that are relevant to construal level theory, and one is like the physical distance, and one is this perspective, right? So here's an example of a very close-up image is these shoes, and a distant image is this kind of like overview shot of the planet. The first perspective is kind of this image almost suggests for you as the viewer to take the perspective of being on that trail, right? Versus the third person perspective, it's like you're looking almost like this bird's eye view over the guy's shoulder. And these are actual exemplars from the database. So this is great. This is exactly what we want to see. However, we have certain images that when they're taken from this very hyper close perspective, there's a tendency for people to actually rate them more likely as being third person instead of first person. even though you could argue that this is more of a first-person perspective. And so that seems kind of weird, right? Like, why would that happen? And if you're interested in kind of like reading a little bit more on this, I'll just put this up here as I talk. So this is something that we predicted in a recent paper. Does anyone here practice mindfulness meditation? Just a couple of people. Is anyone familiar with superrealism as an art form, like Chuck Close and the superrealist, hyperrealist painters? Okay, so superrealism is like this movement that kind of came in the 70s. It was like a response to like ultra modern abstract art. It was like kind of reversing gears and like, hey, let's do something like as realistic as possible. So these are like giant paintings that are actually like from a distance indistinguishable from photographs, like just so photorealistic, but they're, you know, hand painted. Just amazing, amazing stuff. And sometimes they'll take it to an extreme, which is like let's say you got a 20-foot by 10-foot canvas that's like the head of a nail, right? But it's like, and they'll take several photographs to get it from where it's in focus across multiple different views and paint it like that. So it's, no matter how you look at it, it's in focus. So it's like this weird presentation of something that you would actually never really encounter in nature. Right? So even though it's realistic and even though it's really close, it's also kind of deviates from your normal day-to-day perception of the world. And the reason I mentioned mindfulness is mindfulness, you know, the early practices really encourage you to be mindful of like low-level visceral sensations, right? Your breathing, or some mindfulness exercise like put a raisin in your mouth and savor it and move it around and really dig into all of those senses. Well, who does that? We don't do that, right? That's kind of a departure of our normal, let's say, day-to-day simulation of the world. And so we argue that distance and construal don't always go together, that there's actually these kind of orthogonal cases where they might depart from one another. And this might be where they kind of start to violate someone's, you know, day-to-day modus operandi or mode of simulating their environment and their world. And so I think some of these hyper-real images, right, you don't usually get down and have that kind of like 2 inches from your nose, super in focus view of a banana, right? So it even though it's close, it encourages abstraction. It encourages to kind of like almost be disembodied in a sense. That's a theory anyways. And so here's an example of an image, another kind of hyper close image in the database. And this is the distribution of ratings for distance. You can't see the numbers here, but it's on the 100-point scale. So you see like the lower numbers to the left. Pretty good agreement that this is, in fact, a close image. That's exactly what we would hope and expect. However, when we look at the perspective, there's very little agreement. You see it's kind of more of a bimodal distribution where some of the people are like, nope, definitely first-person perspective, no question about it. Other people are kind of in the middle, and then a bunch of people on the right are like, no, I feel more third person. So there's some weird, wonky things going on with these really close-up images. And so what I would like to do is kind of pre-register this as a new experiment, or not really an experiment per se, but more of a study. So the idea would be to gather images that vary across different vantage points, from like far away to extreme close-up, and to make sure that they're all in the first-person perspective. And then so this is now we have a subjective measure of distance that we would get from the ratings. But I'd like to try to find some kind of objective way of classifying that distance as well. And if anyone has maybe like an autonomous driving pre-trained model to recommend, I thought that might be a good way to try to quantify distance. So the prediction here is that the relationship between perspective and distance should be tighter for these far to medium close images. But once you get like super close, that you see those relationships start to break apart. And I think that would kind of fit in with some of the ways we're thinking about how construal theory works in the mind, essentially. So Yeah, so that's kind of where we're at. That's all I had for you today, but definitely thank you very much. Definitely reach out if you're interested in this kind of work. You can see my portfolio site here. I'm happy to connect, happy to collaborate. If you are interested in any kind of weird mad science types of projects. So I'll leave it there. Thank you.
Thank you. Questions? Anybody have questions for Damon?
Yeah.
Great talk, super interesting. I'm just very curious as to why did you use Lava and not GPT-4v directly?
I didn't have access to GPT-4 yet. So this isn't like the end all be all. We'll probably play with a few different models and see how they line up. But yeah.
Cool.
Yeah, I think Lava was the first one. And incidentally, I was able to run it locally on this amazingly as a quantized model, which I thought was pretty interesting. Yeah.
Awesome.
Oh, sorry.
This one's more like kind of related to like the sciencey part. Do you think that lived experience contributes at all to the abstraction? Like, because when I saw the banana, I kind of was like, what you said, like, who looks at a banana that way? Like, your eyes have never seen a banana in that focus. So would you think that, I don't know how you find this, someone who's never seen like a hummingbird from that close or something, is it also to a degree of like, I don't know what that is? So like your sort of sense of abstraction is so far removed? Or do you think it's exclusively based on sort of the visual aspect?
No, I think it's definitely an interaction of perception and sensation, right? So you say the vision's a sensation, but perception is going to be guided by prior experience. And so while we can't predict any given person's reaction to any image, by collecting multiple ratings, we get a distribution. So we can kind of try to predict the average or the average response. So, of course, any given participant is going to have idiosyncratic relationship with any given image. But on the whole, we should be able to predict, like, let's say the negative emotional images are going to, on the average, induce a negative emotional response, regardless of someone's prior experiences. Does that make sense?
Yeah.
Yeah. There's a couple more. Yeah.
How did you choose the categories? It looked like you had roughly 18 of them. And also the example that you shown was a continuum between something that's very alive and something that's not. For all of those categories, is it like that where you could really describe it as one word and then kind of apply a float value to it, a continuous?
Yeah, it was difficult. So, I had several collaborators and a lot of different interests to try to satisfy with this, and a lot of different theories that are coming together on that. So we went through a lot of iteration for deciding the categories and also the text of the question and the appropriate anchors for that. So that one word anchor. So there's a whole paragraph of like more descriptive text that the participant sees to explain what we mean by animacy, for example. Some of my collaborators and I are also in a very different field of research with like more non-traditional psychology, more parapsychology. So researching things like remote viewing and non-local perception. And so some of the characteristics like numinosity is, anecdotally is a big factor for people's remote viewing success. Motion is a big one, and animacy as well. Some viewers are better at picking up like things that are alive versus not alive. And some are more driven by like construal level theory. So like the distance perspective, the social aspects of the image. An image can be social because it's like got a phone in it, or it can be social because it has a people in it. So there's a lot of different characteristics of that as well. So does that answer your question? Does that make sense? Yeah, cool.
Let's take one more question.
I'm just wondering if your hypothesis proves to be correct, what is the real world implication or application of this?
Yeah, so one of my motivators when I started this project was pre-GPT. So I thought that it was, you look at language models and even like image classifiers, and it's really there's this big gap between what's there and what's inferred or what's meant, right? And so going back to the Nazi image, there's nothing in that image itself that a classifier is going to say like, oh, like it's just going to say soldier. It doesn't necessarily have any broader context. The meaning actually it lives outside of the image. Now GPT is like amazing at like bringing in all of that other semantic association. At the time when I was really pushing for this, I thought it would be useful, even in both language and image classifiers, to start to try to understand what's the meaning space of something, not just the objects that are in it or the words of the sentence, right? And so really playing on this idea of semantic space as not being a fixed vector, but that it's a fluctuating vector depending on surrounding context. So while there's been a lot of strides made, forward progression in terms of like relevant models and such, there's still a need for this as far as like a stimulus set or data set for experimentation. So in the lab, like the work that I was doing was emotion regulation. So we would show people these negative images, have them let their emotions unfold naturally on some trials, and other trials they would try to recontextualize or reappraise the image, to think about it differently, to feel better. So if you saw an image of like a car crash, you might think like help is on the way, et cetera. And so our theory, or my theory, was that images like the dog are more difficult to reappraise in that space, because the dogs, all your arousal is telling you should run away. Like if you came across a Doberman ready to bite you, you shouldn't be like, oh, how do I feel better about this situation? Like, no, you got to move your body, right? But if you fail the test, right, then it's not good to like catastrophize it or perseverate on it. You should try to recontextualize it so you can do better the next time. So there's this kind of ecological fit. And that is lost in just valence arousal vectors, right? We need to think about where's the emotion and the meaning of these images really lie, and what strings do I have to pull in an emotion regulation context. I'm happy to talk with anyone after too, if
yeah. We have a place until 8 o'clock, so we can break up and then ask questions and so on. But one last question?
All right, sounds good. Great talk, Damon.
Thank you.
I had 2 questions actually. The first one might be a little bit longer, so I'll lead with that. So you mentioned on one of your beginning slides how you're extracting the last invisible layer, or the last but penultimate invisible layer. And this kind of ties into the first question that was asked. Do you think GPT-4 will enable you to do that? I'm assuming this is because this is an open source model, you're able to extract that. So could you talk more about that? Like, how do you extract that? What is the customization do you have in that?
Yeah, so the process is really easy. It's just an efficient net that I got off of Hugging Face, and you can just specify the layer that you want to pull the embedding, and you just pull the embeddings instead of pulling classes. But since it's a later layer, my understanding is it's kind of convolving both visual and semantic information. So what would be interesting, and one thing I would plan to do, is to try to pull earlier layers. Because if you think like how a model represents even like visual cortex, like early vision is like lines and orientation, versus later it's like more semantic processing. So I think if you wanted to get more strictly just like composition and less meaning, that maybe those earlier layers might be better at that too. So I do want to.
Is this something possible with GPT models? Can you do this on GPT?
Yeah, so it's hard to keep up, right? Like I said, like I've started doing stuff like this is a few months old, and that's may as well be 10 years old in research terms. So I'm not sure. I haven't played with the GPT models as far as visual classification, more for the semantic stuff.
Okay, the second question was about the use case that you mentioned about reverse image search. How do you plan to compete with, say, like a Google reverse image search? Like, what is your scope of what you're planning?
Yeah, that's not really to compete. It's more like if you, let's say you're running an experiment and you want to get images that have these ratings for your experiment. Like, hey, I've got an image of let's say a cat, and I want to get other images that are like this, but that vary in terms of abstraction or vary in terms of emotional intensity. I can do a reverse image search, but also bookend that with like the variables of interest, et cetera. Does that make sense? So it's really just to leverage this data set for other researchers. We're not competing with anyone per se, really. Yeah. 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 Cool. Like I said, I'm happy to talk with anyone else that has other questions, but thank you very much. I appreciate it.
Thank you very much.